Okay, here's our last video, our last section of chapter 12. We're going to do 12.5. We're going to still talk about normal distribution and using either our 68, 95, 99, 7 rule or our z-scores to help us figure out certain percentage and percentile. So we know that the height of adult males are normally distributed with a mean of 70 inches and a standard deviation of 4 inches. We've seen that in previous sections. Suppose we're interested in the percentage of men with the heights below 80 inches. Well, if I go to do my chart, I can put my mean in the middle. I can figure out where my numbers are going to lie if I'm one standard deviation above or below the mean by adding 4 or subtracting 4 because that was the standard deviation. We know from our 68, 95, 99, 7 rule that 68% of men fall in this category. We can do it again for the second 2 standard deviations below by adding or subtracting another 4 inches, and we know that 95% of men fall in this category. That's 95%. And then if we go another standard deviation above or below, we know that 99.7% of men fall in this category. But the question says, what percentage of men are below 80? Well, if you look at our numbers, 80 wasn't on our chart. 80 happens to be kind of in between. It looks like it's in between 2 and 3 standard deviations. But because it's in between, that means our 68, 95, 99, 7 rule isn't very helpful because it doesn't fall at exactly one of those 1, 2, or 3 standard deviations. So here's what we might need to use. This chart down here helps us figure out if we have a z-score that might not be at one of the exact 1, 2, or 3 standard deviations away, and we can't use the 68, 95, 99, 7 rule, we should still be able to figure out what the z-score is, and then we can follow that over and find what percentile we're in. So let's go ahead and do that. So let's use our z-score formula from before, where we know what the data item is. In this case, we're 80 inches. The mean is 70, and the standard deviation is 4. Let's plug that into our z-score formula and calculate what the z-score is for a guy who has a height of 80 inches. I ended up getting 2.5, which should make sense, right? Because remember, this 80 was a little bit between 2 and 3. It actually happens to be exactly in the middle at 2.5. So if you're 80 inches tall, you're 2.5 standard deviations above average. Now, what percentile is that? What percent of men are below 80 inches? That's when we're going to use our chart. We're going to find the z-score of 2.5, if you noticed I've circled it in the purple, and follow it over to the percentile. And so it says that we're in the 99.38th percentile, which means 99.38% of men are shorter or below 80 inches. So that would be our answer. 99.38% of guys are shorter than 80 inches. But I needed to use the chart instead of our 68, 95, 99, 7 rule for that question. So some of the questions on your homework and your test are going to ask you specifically to use the 68, 95, 99, 7 rule. And that's what I want you to use. But some of them don't work out so perfectly where you would need to use this chart. Okay? All right. So let's do a few real quick. Let's look at examples number 1 and 2 in this video using that chart from up above. It says here the distribution of monthly charges for cell phone plans in the U.S. is approximately normally distributed, with a mean of $62 and a standard deviation of $18. What percentage of plans have charges that are less than $83.60? So I need to figure out what percentile we're in, so I know what percent of people pay less than that. I know my data item is $83.60. I know my mean is $62, and I know my standard deviation is 18. I'm going to use that information, and I'm going to calculate the z-score. I ended up getting a z-score of 1.2, which means that if you pay $83.60 a month for your cell phone plan, you are 1.2 standard deviations above the mean. You're paying more than the average person. But what percentage of people pay less than you? Well, let's figure out what percentile we're in if we have a z-score of 1.2. So I'm going to go back to the chart, find 1.2. It's a positive 1.2. That makes a difference, so be careful. And so I end up getting a z-score of 1.2, falls in the 88.49th percentile. If we're in the 88.49th percentile, then that means 88.49% of people are paying less than you. Okay? All right, let's do this last example, and then we'll be finished in this video, and then we'll just do one more example in the next video. We'll finish off with example number 3. But in example number 2, it says lengths of pregnancies of women are normally distributed with a mean of 266 days. So the average is about 38 weeks gestation, and a standard deviation of 16 days. What percentage of children are born from pregnancies lasting more than 274 days? That's more than 39 weeks. Now, we've got to be careful here because now it's asking us for what percentage are more than. Okay? Let's go ahead and first follow the steps of finding the z-score. We know we want to figure out how many are more than 274 days, so that's our data item, minus the mean, which is 266, divided by our standard deviation, which is 16. I ended up getting a z-score of 0.5, so that's half of a standard deviation more than average. Now, using my chart, I need to figure out what percentile I'm in. So 0.5% would be here. Not 0.5%, 0.5 as a z-score would be a 69.15 percentile. So if we are 0.5 standard deviations above the mean, we're in the 69.15 percentile. Now be careful. 69.15 percentile means that 69.15% of people are below you, less than you. Remember, percentile is less than. But that's not what the question was asking. The question was asking how many people are more than you. Well, if 69.15% are less than you, can we subtract that from 100 to figure out how many people go more than 274 days? I ended up getting 30.85%. 30.85% of women go longer than 39 weeks pregnant, longer than 274 days. Using z-scores and using our percentile chart, we can figure out less than, and we can also figure out the percentage that go more than.